Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will solve that integral, which is x to the power of 2 plus 1 divided by x to the power of 3 minus x dx. And the technique that I will be using is the partial fraction decomposition. So if I look at my integral, if I look at my denominator, I know that I can factor out x from my denominator. So my integral become integral of x squared plus 1 divided by x, and it become here x2 minus 1 dx. And now if I compare my numerator to my denominator, in my denominator I have x squared minus 1, in my numerator I have x squared plus 1. Let's put x squared minus 1 in the numerator and see how we're gonna solve it. So I can rewrite that integral as integral of x squared minus 1 plus 2 plus 1 plus 1, which is plus 2, because minus 1 plus 2 is plus 1. So I did not change anything in my numerator, divided by x times x squared minus 1 and dx. Yeah? And now because of that plus that is here, I can split my integral into two integrals. So the first integral become integral of x squared minus 1 divided by x times x squared minus 1 dx plus integral of 2 dx divided by x times x squared minus 1. Now if I look at my first integral, x squared minus 1 divided by x squared minus 1, I can simplify it. I will have integral of 1 divided by x dx plus integral of 2 dx divided by x, and instead of x squared minus 1 I can use a squared minus b squared, which is equal to x minus 1 times x plus 1. Okay, so the solution of the first integral here, 1 divided by x, is log of absolute value of x plus c. I will put the plus c at the end, plus integral of 2 x divided by x minus 1, x plus 1 dx. So the first integral that is here, that is its solution. I will work with the second integral. I will work with this integral, but I will add log of x at the end when I finish solving the second integral. So if I take 2 divided by x times x minus 1, x plus 1, and I use partial fraction decomposition, this will become a divided by x plus b divided by x minus 1 plus c divided by x plus 1. Because they are all of degree 1, that's why I can write it that way. I have a video that explains the partial fraction decomposition. If you look at it at the math tutor, I'm sure you're gonna find many videos explaining that. So let's have a common denominator on the left hand side. So the right hand side, I'm gonna keep it as is, x times x minus 1, x plus 1 equal, I can put a times x minus 1, x plus 1, which is x squared minus 1, plus b times x plus 1, because if I divide x minus 1, x plus 1 by x, I will have x minus 1, x plus 1, which is x squared minus b squared. And if I divide it by x minus 1, I would have those two, plus c times x minus 1. And all that, the common denominator is x times x minus 1, x plus 1. Because I have the same denominator on the right hand side and the left hand side of my equality, I can take them out. I would have 2 equal ax squared minus a, so I distribute my a inside my parentheses, plus bx squared plus bx, times 1 is bx, plus cx squared minus cx. So now I can factor out x squared, so I would have 2 is equal a plus b plus c, factor out x squared, and here let's highlight bx and cx, I can factor out x here, so plus b plus c times x, And I would have minus a, I keep minus a. Okay? So if I look a plus b plus c times x squared on the left-hand side, I don't have any x squared on the right-hand side. That means my a plus b plus c is equal to 0. And then I have b plus c, factor out x, but I don't have any x on the left-hand side. So that means my b plus c is equal to 0. And my minus a would be equal to 2, because minus a does not have any coefficient and the 2 does not have any coefficient. That means my a is equal minus 2. So I will use this. Here I have minus cx and I put plus c here. So that should be minus here, yeah. If I want to factor x here, I would have b minus c. So this become b minus c equal to 0. So from the second equation, I can deduct that b is equal to c. And the first equation, I will replace a by minus 2. And I will replace b by c, plus c is equal to 0. That means 2c is equal to 2. That means c is equal to 1. And because b is equal to c, that means my b is equal to 1. And I have my a is equal minus 2. So now that I can write it as a, this is become minus 2 divided by x, and my b is equal 1 divided by x minus 1, and my c will become 1 divided by x plus 1. So my integral of 2 divided by x times x minus 1 times x plus 1 dx, I can write it as integral of my a is equal minus 2 divided by x dx plus my b is equal to 1, we said. 1 times dx is dx times x minus 1 plus my c is equal to 1 and x plus 1 here. And I have dx. Let's write it. 1 times dx is dx, so let's write dx here. Okay? So that integral, the minus 2 would go outside the integral. It becomes minus 2, and the integral of 1 divided by x dx is log of x, absolute value of x, plus log of absolute value x minus 1, plus log of absolute value of x plus 1. And let's move it a little bit. And plus c, but I have to add this log x here. So I would have, which is equal to log x minus 2 log x plus log of x plus 1 plus log of x minus 1 plus c. So I have log x minus 2 log x, it become equal minus log x plus log of x plus 1 plus log of x minus 1 plus c. I know, you can keep it that way, or you can say minus log of x plus log of x plus 1 times x minus 1 plus c. This is the logarithmic rule. So log a plus log b is equal to log a times b. So this become minus log x plus log of x squared minus 1 absolute value plus c. So, and like if you stop even here, it's okay. if you stop here, it's okay, but if you want to continue, it becomes log of x squared minus 1 divided by x, the absolute value is everything, plus c. And that would be the final answer. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.